Hello, welcome back, viewers. So in this video, we'll be looking at the graphs of tan and cotan. So we'll start with this type of graph where you have just a stretching and shrinking. So for the graph of tan, something very important is that the tan graph is what? The tan is of period pi, right? Is of period pi. So if you want to find the period of tan, we use pi over k. So k could be 1, k could be 2. And we know that tan has what? Tan has some vertical asymptotes, right? So, but one complete cycle of tan is completed in where? From minus pi over 2k up to pi over 2k. That is the interval. So let's discuss that of tan first. We know that if you have tan x is nothing but sine x over what? Over cosine x, right? So it means it's going to have two things. It's going to have x-intercept. And what will be x-intercept? X-intercept will be the zeros of the numerator. You can get it from sine of x equals to 0. And then if you want to get the vertical asymptote, the vertical asymptote, you get it from the zeros of the denominator, which means that cosine x is equals to 0, right? So it means that if we want the graph, and what do we mean when we say sine x is equals to 0? It means x is equals to n pi. And cosine x is equals to 0 means x is equals to what? Pi over 2 plus n pi, right? So let's just begin with this example now. Sketch the graph of one period of tan x. So for one period of tan x, if you look at this particular one, what is our a here? Our a here is simply 1, right? And we see that what the period is just going to be tan over pi over k, which is just going to be pi, because k here is 1. If you compare with a tan kx, you see a is 1 and k is also 1. So let's see one complete cycle. For one complete cycle will be from pi over 2k minus pi over 2k to pi by 2k. So, and this means that what? If you substitute k equals to 1, it's going to be from minus pi over 2 to pi over 2. It means that if we want to graph, we will start from minus pi over 2, and we stop at where? Pi over 2. And now, if you look at this, what is the distance between pi over 2 and minus pi over 2? It's going to give us pi, right? Which is the period. Okay. So now, as usual, we divide this period into what's this period pi, we divide it into 4. So the midpoint here, what will be the middle? This is going to be 0, right? Because you will have pi over 2 plus, so you have pi over 2 plus minus pi over 2, everything divided by 2. This is going to be 0 over 2. So the center is 0. Okay, then also you find the center here is going to be pi over 4. This also you find the center. This is minus pi over 4. All right. Now, if we sketch this to be our, this is our x or y-axis. I mean, this is our y-axis. So what is the a? Our a is 1, and our minimum value also is going to be minus 1 here. Not the minimum value, but just the a and minus a. Okay, now one thing we should know about tan is that what? We can just find the values directly. So if we're looking for tan 0, what is tan 0? Tan 0, we know is what is 0, so it means tan 0 is this. Then tan 4 over 5, 4 pi over 4 is 45. Tan 45 is 1. Then we know that tan 90 is not defined, yes, because tan 90 is what is sine 90 over what? Cosine 90, right? But sine 90 is 1. Cosine 90 is 0. So we have 1 over 0. So this is undefined. And this tells us that we have a what? We have a vertical asymptote. We have a vertical asymptote here at where? At pi over 2. And also we also have at where? At minus pi over 2. And that is why you can see you have these intervals to be open. So your vertical asymptote for one period will just be at those endpoints. All right. So this is what next? All right. So it means that this is just going to be a point like, let me reduce this one. Let's make it 1 here. So we are here. So it means it's just going to be something like this. You get close to the asymptote now, but without touching it. Then at minus pi over 4, which is tan minus 45, is going to be minus 1. So we are here. So this is also going to be, let's shift this point a little bit here, minus 1. So it means we're going to have this also. So this is like also a curve. But now you have another vertical asymptote here, which is at this. So this graph is just one period of what? Of tan x. And you can see you have two vertical what? Two vertical asymptotes. Now let's assume you want to draw two period. If you need two period, it means you can draw it in any side. You can draw it to the right or to the left. If you want to draw it to the left, it means you need to add pi to pi over 2. So it's going to be 3 pi over 2, right? Then you divide this interval into 4, and then you do the same thing. So it's very easy. Once you have the interval divided into 2, the midpoint of the interval will be your what? Will be your x-intercept 0. Then when you go to the right, you just go to the highest point, which go to your a. When you go to the left, you also go to your minus a, which is this. But one thing we should note is that the range, let's assume if you have to find a range, the range you can see is from minus infinity to infinity because it keeps going. The range is not minus 1 to 1, okay? So the range is from minus infinity to infinity. And what is the domain? Is going to be the whole R, the same thing, minus what? You have to remove the vertical what? The vertical asymptotes, okay? So in this case, for one period, you are only going to remove minus pi over 2 and what? And pi over 2, right? But if in general, you need to remove the general, what do you call it? Vertical asymptote, which would be the zeros of sine x, the zeros the zeros of cosine x. So it's going to be like, what are this vertical asymptote? It's just going to be pi over 2 plus n pi, where n is what is an integer. All right, so this is how to draw the graph for tan x, just one period. So in the same way, let's draw one period of what? Of cotan. Now, for cotan is similar. We need to discuss this. I think we have it here. For cotan, the period is also what? Pi over k, but one complete cycle is completed in what? From 0 to where? To pi over what? K. This is simply because the vertical asymptotes are different. Remember, the vertical asymptote for cotan is going to be the zeros of sine. And what are the zeros of sine? They are n pi. So let's do this now. Okay. So if you want to sketch the graph of cotan, how do we do it? The same way. What is K? K is 1, A is 1, K is 1, right? So it means that the period, so the period is what? Is still pi over K, which is going to be pi over 1, which is pi. Then one complete circle will be from 0 to pi over K. So what does that mean? It means this is going to be from 0 to pi. Now what that means is that we will have from 0 to pi, and then we have to divide this into 4. So the middle is what? Pi over what? 2. And this is going to be pi over what? 4. And this is what? 3 pi. 3 pi over 4. Now, so let's say this is our, so this is, let's say, our 1, and this is minus 1. Right. So the same way, we just start from where? We start from the midpoint, right? What is our midpoint here? Our midpoint of the 4 interval, that's what I mean. So you see the 0 will be from where? Here. This is the x-intercepts. Yes, then when you go to the what? When we go to the right, when we go to the right here, in the case of tan, we go to 1, but in the case of cotan, we should go to we should go down. And why is it like that? Because we are looking for tan 3 pi over what? 3 pi over 4. If you look at 3 pi by 4, is in which quadrant? This is definitely in the second quadrant, right? So since in the second quadrant, well, in the second quadrant, we know that tan is negative. So this will become minus tan, right? In the second quadrant is pi minus what? 3 pi over 4. So this is minus tan of what? Pi minus 3 pi over 4 will give you pi over 4. So this is just minus tan pi over 4 is 1. So you have minus 1. So that is why we are here, right? Okay. So what next? But we also have 2 vertical asymptotes. We should think about that also. So the vertical asymptote will be at the endpoint, which will just be at 0 and what? And pi. So there will be a vertical asymptote here. And there will also be a vertical asymptote at where? So let me use a different. So we have vertical asymptote here. And also vertical asymptote here. So what that means, it means from here, you're going to cut this and you'll keep getting close. And then we check here, this is tan 45, which is definitely going to be this one. So this is going to be like this. And we're done. So this is because this is the graph of what? Of cotan x, one period of cotan x. So we can add so many periods. You can add one period to the right. You can add one period to the left. So depending on how many periods you want. But for one period, this is fine. This is the graph of cotan x. So let's see this one now. So let's look at this one. Example 10. Sketch the graph of one period of what? Of tan x. In this case, your a is still equals to 1, but k here is what? Is 2. So it means that the period, remember, for tan is just pi over k as well. So it means the period is pi over what? 2. So one complete circle will be from where to where? Will be from minus pi over 2k to pi over 2k. And that means that it will be minus pi over, so you have 2 times 2 because k is 2. So this will just be minus pi over 4 and also pi over what? Over 4. So this is what we're going to deal with now. So we will deal with the interval minus pi over 4 and then pi over 4. Automatically, this will become our what? Our vertical asymptotes. Okay. So we divide this interval into 4. The midpoint of it will be the center, which will be what? You have minus pi over 4, then minus pi over 4. So this is going to be 0, right? That will be the center. So here is going to be pi over what? Pi over 8. And here will be minus pi over what? Over 8. And we're done. So this is the graph of tan. So since this is the graph of tan, the midpoint will be your x-intercept. When you move to the right, okay, so let's draw our y-axis. What is our a here? Our a is still 1, so this is still 1, and this is still minus 1. So if you move to the right, you'll have the point here. So you will have, okay, let me bring this down a little here, 1, and also minus 1. So here will be just this one. So we have this, and then minus 1 is here. So we have this one like this. All right, so this is the graph of what? Of tan 2x. So this is the graph of what? Of tan 2x, one period of it. And now you can try to check whether you are right or not. You can just take any value. For example, let's try, the function itself is what is. The function itself, or f of x, is tan 2x. So we can check f of what? Minus pi over 8, which will just be tan 2 times minus pi over 8. And what do we get? This is just tan minus pi over 4, right? And this is just minus tan pi over 4 because tan is odd. And this is just minus 1. Yes, and you can see we are fine here. Okay. Then example 11. for example, 11 is dealing with what's with cotan. So here, the same thing. What is our A? Our A is still 1. K is what is half. So if K is half, then the period pi over K is pi over what? Pi over half. And if this pi over half, this will just become what? 2 pi. And since this is cotan, right? So remember, one complete circle for cotan is from 0 to pi over K. And this is going to be from 0 to pi over half, which is just 0 to 2 pi. Right. Now, 0 to 2 pi, what does that mean? It means that the graph will be from, we can start from 0, and then will be 2 pi. So that is also to say that we have vertical asymptote at the endpoints, 0 and 2 pi. Then the middle here is going to be just pi. And here will be pi over 2. And here will be 3 pi over 2. And that's it. This is also, so what is the value of A here? A is 1, so this is going to be 1 minus 1. And then at what is the middle of the interval is pi. So it means here is going to be 0. It's going to be the x. Then when you move here, it's going to be at 1. So we'll have something like this. Then here at pi over 2 is going to be minus 1. So also this way. And we're done. This is the, sorry, this is the graph of what? Sorry, graph of cotan, not the graph of tan. So this is not true. Yes, this is not true. We're dealing with the graph of cotan, right? For graph of cotan, once you move to the right, you should go to the minimum. And once you move to the left, you should go to the maximum. So this will be the graph. Yep. And then you can always check. You can always check. Now, what is our function here? Our function is, I think it's cotan 1 over 2 of x, right? So let's check for f of what? 3 pi over 2. This is going to be cotan of what? So this will be 3 pi. This will be now half times 3 pi over 2, right? And this will just be cotan of what? 3 pi over 4. And what is cotan 3 pi by 4? This is the same thing as minus cotan of what? Pi minus 3 pi over 4, because cotan is in the 3 pi by 4 is in the second quadrant, right? Since in the second quadrant, you can, this is in quadrant 2, right? And cotan in second quadrant is negative. We can use the reference angle. So this is minus cotan of pi over 4. This is just minus 1. All right, so the next one is going to be transformations when we have also a vertical what? A vertical shift as well as horizontal shift. All right, so here now we'll be looking at equations, graphing where you have a vertical, a horizontal shift. So it's still going to be the same procedure. This we can just rewrite. How can we rewrite this? We can rewrite this as 3 tan. We can take the half inside, so you have x minus 2, and this is pi over 6. Here, this is y, so we can say the period is the period is pi over k, which is just pi over over 2, because our k is 1 over 2, and we have this one, right? But here we also have the horizontal shift, which is going to be x is minus b over k, and this is going to be minus, what is b here? B is minus, so you have minus pi over 6 over 6. Okay. Now, if you look at this here, what is k? This means that k is what? Yeah, we know what is k, so let me just write everything here. Our k is 1 over 2, right? K is 1 over 2, so the period is going to change. So let's put things in. A is what? 3. K is half. B is minus pi over 6. And C is what? 0. Okay, because we are comparing it with what? We are comparing it with y is equals to a tan kx plus b plus what? Plus c. All right, so the period, remember, is pi over k. All right. So the period is pi over k, which is just pi over k, which is half. And this is just going to become 2 pi. All right. But here you have that the horizontal shift is x is equals to minus what? It's just going to be pi over 6, right? But remember, you have divide by half. So x is going to be just pi over 6 divided by half, which is pi over 6 times 2 over 1. So x is pi over 3. This is our horizontal shift. But also, we know that one cycle, we know we have a period, right? But one cycle of tan is completed between what? Minus pi over what? Remember, it's minus pi over 2k to what? To pi over what? 2k, right? But now if you put our k, remember the k is what? K is 1 over 2. So this will become just minus pi to what? To pi. Because if we substitute k to be half, then we'll have what? Minus pi to pi. All right, so it means originally, this is what it's supposed to be. Originally, we're supposed to have the graph to be from minus pi to what? To pi. This is what it should be without considering the what? The horizontal shift. Is that okay? All right. So now let's work with this. Then we can readjust. But look at the distance. What is the distance from minus pi to pi? It's just 2 pi, right? So it means the middle here is going to be 0. And this is what? Pi over 2. And this is minus pi over what? Minus pi over 2. But now we have a horizontal shift. So the horizontal shift is what? Our horizontal shift, you can see, is pi over 3. So we need to add what? Pi over 3 to each one, each of this point. So it means that the graph is just going to start from where? This is minus pi plus pi over 3. So this one is like, because here you have minus pi, so it's minus 3 pi over 3 plus what? Plus pi over 3. Is it because you're adding pi over 3 to everything? And this will just give us what? Minus 2 pi, yeah, minus 2 pi over 3. Then for this one, this is minus pi over 2 plus what? Pi over 3. We can multiply this by what? By 3 over 3. You can multiply this by 2 over 2. So you have minus 3 pi plus 2 pi. And that would just give us minus pi over 6. And this one will give us pi over what? 3, right? And this one is going to be 5 pi over 6. And finally, this one is going to be 3 pi over 3. So it will be 4 pi over 3. Okay. Now, this is the interval we're going to work with. So we work with this interval here. And I can remove it. Okay. So this is what interval we're going to work with here. Now, this means that you are going to have the vertical asymptotes. Our vertical asymptote will be at where? At those ends point. Right. So where is the middle? This is the midpoint, which is this. So this will be the zeros. So we can have, let's draw our line. Let's say we can have 0 somewhere here. And our A is going to be 3. So 3 will be here. And minus 3 is going to be somewhere here. Now, since this is our midpoint, so this is going to be 0. And when you go to the right, you will go to the highest value, which is this. And when you go to the left, you will go to the lowest value, which is this one. So the graph is just supposed to be something like this. And then like this. Okay. So this is going to be the graph of what? So you can see that this is a graph that has a shifting. It has a horizontal shift. So that is why it's looking like this. And also you can always test your values. You test your function by picking any value and substitute into the equation. So for example, this is the graph of what? 3 tan. When you take the half inside, so this becomes x over 2 minus pi over 6. So let's try this one. Let's try what is f of pi over 3. It's going to be 3 tan. Pi over 3 divided by 2, it becomes pi over 6 minus what? Pi over 6. This is just going to be 3 tan 0, which is just going to be 0. Okay, so this is the graph, and we have the vertical asymptote will be at pi over 3, 4 pi over 3, and minus 2 pi over 3. So let me just repeat what I did here. So here, just write it as a note. It's important here. we're supposed to start from minus pi to pi, and this is become 0. This is what's minus pi over 2, and this is what's pi over 2, right? Then what we did was that for each interval, we added pi over 3 because this is shift to the right, right? So it's like you have to add pi over 3 to each of the interval, pi over 3, you add pi over 3, we added pi over 3, and here also we added pi over 3. So once we do that, our new interval now became minus 2 pi over 3 to minus pi over 6, then to pi over 3, 5 pi over 6, and then 4 pi over 3. Okay, so that is the interval we use for the graph. Okay. Now for this one is a similar situation. Here we have a vertical shift of what? We have a vertical shift of 3, but we are dealing with the graph of cotan. So what we can do, it's this we can write as what y is equals to 2 cotan x over 2 plus 3, right? So if you compare with y is equals to a cotan kx plus b plus c, right? It means that our a is going to be 2, but this a in this case is not the amplitude. The graph of cotan and tan, they do not have amplitudes, right? Because, you know, there's no maximum, there is no minimum for them. So we just called it a, we don't call it amplitude. So here, k is what is half, and c is what is 3. So the period for cotan is nothing but pi over k also. So this is pi over k is still half. So this becomes what? 2 pi. But we know that one complete circle is between 0 and what? Pi over k. So this is 0 and pi over, what is k? K is half, right? So this is between 0 and what? 0 and 2 pi. Yes. Unlike in the case earlier, it was minus pi over k, all right, minus pi over 2k. So this is what we need, but we also have a horizontal shift for this graph. Horizontal shift is minus b over k. This is going to be minus, b is 0, right? Yeah. So b is 0, so it's just going to be b 0 over whatever is k. So x is equals to 0. So it means there's actually no horizontal shift. So we're going to start from 0. So it means that we just need to try to sketch this one. We're going to start from 0 and we end at 2 pi. You see, there is no horizontal shift, so there is no need to subtract anything or add. The midpoint here is pi, and here is pi over 2, and this is what? 3 pi over what? 3 pi over 2. Right, now, what can we do here? This we know that we're going to have 2 vertical asymptote at 0 and at 2 pi. But the A for this question, there is something which we need to talk about, is the what? The 3. So there is a plus 3. So since there is a plus 3, it means that you have to go up. This is like our baseline. So this is the plus 3, right? And then you have to go 2 because you have A, right? So this is our baseline and our A is 2. So it means that we will have to go here, which is going to be 5, right? And from the base here also you have to go down 2, which is going to be 1, right? Yes. Okay. Because our A is what? Is 2, right? So it means the distance from our baseline to our highest point should be 2. So this is 5 and this is 1. Now let's try to put the point now. So just like we said, here now, where is our midpoint? Our midpoint is pi, but this is our baseline now. So our baseline is 3. So we'll have to start from here. We're not starting from here because the graph has been shifted up 3 units. So this is, so we're here. Then once we move to the right, which is at this point, we will go to the highest value here, which is going to be 5, because we're dealing with the graph of cotan. So we should go to the minimum, which is going to be this one here. Then when you go to the right, we should go to the maximum, which is going to be 5 here. So we're done. So this is just going to be something like this. Okay. Then we're still going to 4. So this is like one period of it. Yes. So this is our function f of x is equals to 3 plus what? 2 cotan x over 2. And now you can check, for example, you can check with what? I think this one is not really in a good position. It should be somewhere here. Yes. So it means, for example, now if you substitute, let's look for f of what? Pi over 2 is going to be 3 plus what? 2 cotan. This is going to be pi over what? Pi over 2 over 2. This is pi over 4, right? But what is cotan pi over 4? This is 2 times 1. So which is what? Which is 5. So this is just to test the point. And I think it's fine here, as you can see here. This is 5 here. All right, this is very important because here we shifted the whole graph 3 units upward. So that is why we can reach as high as 5. All right, let's see example. Okay. Now example 13. Okay. So for example 13, it says the graph of the function from 0 to pi is below the x-axis on this one. So here, we're still going to graph the same procedure we did, but here, remember, look at the interval we're interested. We're interested in the interval 0 to what? 0 to pi. So here we need to look at what is A. For example, here A is what? A is 2. K is what? Is 2. And B is what? Minus pi over 2. So the first thing I will get is the period, which is pi over k, and this is going to be pi over 2, right? Because k is 2. Now we can get the what? We know that one complete cycle is usually from 0 to what? Not 0. This is the graph of tan. So one complete cycle is from minus pi over 2 to so minus pi over 2k to pi over 2k. So this is what we should have. Minus pi over 2k to pi over what? 2k. But what is this? This is going to be minus pi over, if you substitute k, so it should just be minus pi to pi. No, because k is 2, so it's going to be minus pi over 4, right? Yeah, because our k is 2, so this is what we have. All right. Then now, do we have a horizontal shift? So let's see our horizontal shift. Our horizontal shift is what? Is x is equals to minus b over k. And this is minus, what is b? B is already minus, so you have minus pi over 2, everything over k, which is 2, right? So this is just going to be pi over 2, then divided by 2 again. So this is about pi over 4, right? Okay, so let's just discuss this one now. Now, it means originally we are supposed to start from where? We are supposed to start from, because this is a period, we're supposed to start from minus pi over 4 up to where? Up to pi over 4. This is what it should be. But if you look here now, we are adding what? We have to add pi over 4 to each of these interval, right? So let's see this one. What will be the middle here? The middle here is supposed to be, if you add this and this is going to be 0, and this is minus pi over 8, and this is supposed to be pi over what? Pi over 8. So this is just for, if you will use the what? The one complete cycle when k is 2, right? But we're going to add what? We're going to add pi over 4 to each one. Okay. Now, if you add pi over 4 to each interval there, what do we get? It means that the first one, this is just going to be minus pi over 4 plus pi over 4. I think this is going to be 0, right? Okay. Then this one, you have minus pi over 8 plus pi over 4. So we'll have minus pi over 8 plus what? Let's say 2 pi over 8, yes? And this is just going to be pi over 8. So here will be pi over 8. And here will be pi over 4. And this one, you have pi over 8 plus what? Plus pi over 4. So this is 2 here. So this will be 3 pi over 8, right? And then here you have pi over 4 plus pi over 4. So this is 2 pi over 4, which we can just leave it as 2 pi over 4. Okay. Now, but if you look at what we have, we are interested in the graph from where? From 0 to what? To pi. Okay. So this, you can see that we don't have enough yet. But how do we work around with this one? Okay. Because right now, this is what we have. Let me draw it here for us here with another one. So right now we have from this to this. Our starting point is what? 0. And here is pi over 8. And here is pi over 4. And here is 3 pi over 8. And here is 2 pi over what? 2 pi over 4. So you can see that this is not up to where? It's not up to what we need. We need what? We need from 0 to pi. So in this case, what you need to do, you need to keep increasing the what? The so it's going to be more than one period, right? Now, if you look at the difference, what is the difference between all of this? You will see that each interval is a distance of what? Is a distance of pi over 8. Because this is 0, this is pi over 8. If you add pi over 8 to this, we're going to get pi over 4. If you add pi over 8 to this, you're going to get this one, right? Look at it. If you have pi over 4, you add pi over 8. What do we have? This is going to be 2 pi over 8, so it will be 3 pi over 8. So it means if I want to get the next value here, the next point, let me use a different a marker here. Let me use a different pen. So if I want to get the next point here, all we need to do is to add what? Pi over 8 to this one. And if you add pi over 8 to this, here you can multiply by what? By 2 over 2. So you have 4 pi, right? Then you add pi, so you have 5 pi over what? Over 8, right? Then you add another pi over 8. If you add another pi over 8, so you have 5 pi over 8. Then you add another pi over 8. This is going to give you 6 pi over what? 8. So here is going to be 6 pi over what? Over 8, right? Okay. But what do we do again? 6 pi over 8. Remember, we need what? We need pi. We just need to get from 0 to pi. So have we passed pi already? If this is pi over 2, I think this is also going to be enough. All right, so you can see that it means we can still add maybe about 2 points before we get to pi, right? So if you add pi over 8 again here, you're going to get 7 pi over 8. If you add another pi over 8, you will get 8 pi over 8. And remember, 8 pi over 8 is the same thing as pi. So this is actually like 2 periods that we are graphing, right? So the same way here, this is, if this is 0, then what is our A? A is 2. So this is going to be 2, and this is going to be minus 2. Now, don't worry. We're going to be graphing this. This is actually more than one period. Remember, our original period starts from 0. This is our original one. So from 0 to where? 2 pi over 4. So it means at this 0, we're going to get a vertical asymptote. Also at where? 2 pi over 4, we are going to get another vertical asymptote. And clearly, as you can see, at pi, which is at this one also, we are going to get another what? Another vertical asymptote. Now, try to see. You will realize that the period has not what? Has not changed. Remember, what is our period? Our period is pi over what? Over 2. And that you can see, what is the distance between, what is the distance here? The distance here to here is what? This is 2 pi over 4, which is pi over 2 minus 0. So this is pi over 2. Here, what is the distance between, look at this, this is 8 pi over 8, which is like pi, right? And this is what? 2 pi over 4. What is 2 pi over 4? You see, this is pi over 2. And what is 8 pi over 8? This is pi. What is the difference? pi minus pi over 2 is still what? Is still pi over 2, right? So the distance from here to here is also what? Pi over 2. So it means actually this graph is requesting us to graph 2 period, not 1 period. Okay. Now, so let's see how this goes here. So let's focus on 1 period. If I'm focusing on 1 period, what is the midpoint of this period is what is pi over 4. So at pi over 4, I'm going to have it at 0 because we don't have a vertical shift. And when I go to the right, I'll go to the maximum value, which is going to be 2 in this case. Not the maximum value, just 2. Then when I go to the left, it's going to be minus 2. So it means that for the first period, we're going to have something like this one, right? And in the second period, you do the same thing. Second period, go and locate the center. Where is the center? It's 6 pi over 8. So it means at this point, you will be at 0. Then when you go to the highest, when you go to the right of your center now is at 7 pi over 8. At 7 pi over 8 also, you should get to 2. Then when you come back at 5 pi over 8, you should be at where? At minus 2 as well. So you're going to have something like this one also. Okay. So you see, it's the same pattern, right? But don't forget that this one will keep going to infinity, and all of this will be going to infinity, and these ones will come into minus infinity. So now we can look for what we want. We are looking for where the graph is what? Is below the x-axis. So below the x-axis is just from here, as you can see, from minus below the x-axis. We have 2 parts. The first part from here is from 0 to where? To pi over 4. Then union, the second part is going to be from where? 2 pi over 4. 2 pi over 4 to where? To 6 pi over 8, right? And what is this? This you can rewrite it as 0 pi over 4 union 2 pi over 4 is the same thing as pi over 2. And this is the same thing as 3 pi over 4. And we're done. Okay. Now, example 14 is asking for where? Okay, I think we can stop here for this one. Example 14 is just the algebraic way. I think this is fine. We can stop here. So thank you for watching. This is how to graph these kind of functions for tan and cotan, where you have both translations, vertical translations, and even when you have a horizontal translation.